good morning to all of you. Hope you are all fine. We will start from Unit 6. Unit 6 is titrometric analysis, as you can see, redox titration. Before we go, I would like to elaborate some fundamental concepts about volumetric analysis. Okay students, so let's start. A quantitative method of analysis dealing with the volumes of solutions and their measurements is termed as volumetric analysis. In this method, a known volume of one solution is taken in any glass vessels, as well as you can say conical flask as well as titration flask. To this, another solution of a substance is added little at the time till the reaction is complete. This process is known as titration. As you already know in 11th Science Standard, the stage during titration at which the reaction is just complete is known as the equivalence or end point. Now we will learn what is standard solutions. Standard solution is that solution whose concentration is known, that is, one solution has known concentration. Strength of solution. It is defined as weight of the solute in grams dissolved per liter of the solution. Its units gram per liter. Standard. A substance whose solution can be prepared by dissolving an accurately weighed amount of it in water and making up the solution to a known volume by dilution with water is referred to as primary standard substance or simply primary standard. A primary standard should fulfill the following requirements. That is, first, it should be easily available in highly pure state. Second, it should be readily soluble in water. Third, it should be neither hygroscopic nor a fluorescent. Fourth, it should be stable and unaffected by air. Fifth, it should have large equivalent weight so that the weighing errors are minimized. Sixth, its composition should not change on standing during storage. Crystallization. You know already. Crystalline oxalic acid, sodium oxalate and more salt, as well as you can say more salt is as ferrous ammonium sulfate, are used as primary standard. Secondary standard. We will learn here what is secondary standard solutions. Those substances which do not fulfill the above requirements and their standard solutions are not prepared directly by weighing are called secondary standard substances or secondary standards. An approximate weight of the secondary standard is dissolved in a known volume, and the exact strength of the solution is found by titrating it against standard solution of suitable reagent. This process is called standardization. Here in redox titration we will use K-4 as a primary standard. Why K-4? We will learn here. K-4 is not used as a primary standard because of the following reasons. First, it is always impure and associated with manganese dioxide. It is difficult to prepare it in pure condition. Second, ordinary distilled water contains organic matter which may oxidize K-4 to MnO2. The presence of MnO2 is very objectionable because it catalyzes the auto decomposition of K-4 solution on standing. Due to these reasons, a standard solution of K-4 cannot be prepared by exact weighing. The solution is first prepared, kept for some time, filtered through purified glass wool, and is standardized against standard oxalic acid solution. Now we will learn redox titration. What is the redox titration? In redox titration, that is, two reaction occurs, first oxidation and second reduction. In redox titrations, a reducing agent is titrated against an oxidizing agent or vice versa. Redox titrations involve redox reactions. In such titrations, potassium permanganate, potassium dichromate are the commonly used as dioxide agents which are titrated against reducing agents like oxalic acid, ferrous ammonium sulfate, as you can say, more salt. Redox titration involve following reactions. First, we will learn about oxidation. What is oxidation? It is a process in which the oxygen or any electronegative elements is added up. Hydrogen or any electropositive element is removed or electrons are released. When Fe2 plus ion loses one electron, it changes into ferric, that is Fe plus 3. This process is called oxidation, and ferrous ion is said to be oxidized to ferric ion. You can see the next equation. Second, reduction. What is reduction? It is the process in which hydrogen or any electropositive elements is added up. Oxygen or any electronegative element is removed or electrons are accepted. When cupric ion accepts 2 electrons, it changes into copper atom. This process is called reduction, and cupric ion is said to be reduced to copper atom. See the equation. What is redox reaction? Redox reaction. If in a chemical reaction one substance is oxidized and the other is reduced, it is called redox reaction. In other words, oxidation and reduction occur simultaneously. Consider the following reaction. Potassium permanganate titration. We can say redox reaction titration as well as potassium permanganate titration. Potassium permanganate is a powerful and versatile oxidizing agent. It is widely used for titration against reducing agents like oxalic acid and more salt. Redox titration involving potassium permanganate as an oxidizing agent are termed as potassium permanganate titrations. Importance of acidic medium. Here in redox titration we will use acidic medium. Why? We will learn here. In most of the potassium permanganate titrations, solution of the reducing agent should be made acidic before carrying out titration. In acid solutions, reduction of potassium permanganate is represented by the following reaction. See the equation. MnO4 negative aqueous 8H plus aqueous plus 5 electron. It gives Mn2 positive aqueous plus 4 H2O. Here MnO2 negative is permanganate ion which is already pink. Then converts in Mn2 positive aqueous, that is manganese ion which is colorless. Of all the 3 common mineral acids, only sulfuric acid is found to be suitable for making the solution acidic. Here we will learn why we only use sulfuric acid. Under the titration conditions, it does not react with potassium permanganate or reducing agent used. Detection of endpoint. Potassium permanganate is a self-indicator. It forms purple colored solution. During titration reduction of potassium permanganate by a reducing agent like oxalic acid or more salt produces manganese ions, which are nearly colorless. As the titration proceeds, and when the whole of reducing agent is consumed up, then the addition of an excess drop of potassium permanganate gives its own color, that is pink color, to the solution. Therefore, at the end point, the color changes from colorless to pink. Here, in redox titration, we will use KMnO4 versus oxalic acid and ferrous ammonium sulfate, that is here more salt.